Okay, I've got a couple microwaves here that we're going to be tearing down and taking the transformers out of. As well as the transformers, there's a capacitor in here that's not useful for very much, but it is a cool part to take out and keep around. These control panels here, they actually all come out in one piece, and I think it's basically a timed relay, so you can use this whole panel to use on timers for other things. If you built a DIY annealing heater or something like that, or annealing oven, you could use this to control that annealing oven for certain periods of time. So there's some good parts out of here that I want to take out. It's actually relatively clean for one picked up off the side of the road. I do like to keep these plates because they are good for, you know, putting plants on and things like that outside. There. Okay, first things first, I'm going to turn this thing on its bottom. Take any screws out of the side casement that I can see. Like there's none over there. None over there. Face. And we can see there's plenty back here. So, some kind of wire back here. Obviously somebody was using that to maybe tie up the cord, tie up the excess for the cord. That's not a bad way to do that. It is a little bit dangerous given there is a motor right there. And I think that motor does run on mains voltage for the chassis fan. Let's see if I can cut this out of the way. There we go. Go in the trash can. And okay, we've got some Phillips there, but it looks like we actually have some security bits here. So what I'm going to do, I'm going to get into my security bit here, see if I can't find a size for it. These little kits can be bought at Harbor Freight all day long, and I have found them so useful. That's a little bit too big. Go to the next size down. There we go. That'll work. Go ahead and take our driver here and back these on out. One down. Two down, and when this casement comes loose, it should lift all up off of the chassis at once, and it should stay clear of any capacitors or anything. That capacitor that I mentioned earlier is absolutely going to need to be discharged. I think it's very unlikely that it has any charge left, but famous last words and all that. Starting to get that casement popping loose. Okay, looks like we might have something here. There we go. Ta-da! There we go. That'll be going to the metal guy. Okay, what you see here, opening this up, you see the internal structure of the microwave here. You see a couple of thermistors that basically turn this thing off if it gets too hot. You see one here, one here. I believe this is a temperature unit here. Might be some kind of flow meter, basically telling the computer how much air is being forced through here. You have the magnetron back here, and you have your whole cavity back here that is shaped a certain way to reflect those electrons into the cavity in a certain way. There's a great video on YouTube, I will link it down below, where the guy basically goes through these magnetrons and shows you exactly why this cavity is shaped this way. It's about as complex as a speaker housing. If you've ever looked at the math behind a speaker housing, to make a speaker box is very specific to the type of the speaker, the size of the speaker, and the type of sound you want. So it's very interesting stuff. Moving along here, I'm going to put this thing on its side and show you. Our beautiful microwave oven transformer here, and we've got our capacitor. So that capacitor is where we're going to want to go ahead and short out and make sure there's no charge left in there. So what I'm going to do, I'm going to try and pull off those connectors very carefully. There's one. Very careful with this stuff. You don't want to short anything out to the chassis, which is exactly what the risk is here. That sucker is not wanting to come out. So what I'm going to do, I can get to the top of that plug on the back side of that wire, and I can get to this side just fine since I was able to get that one undone. So what I have here, I have two pieces of bamboo stick, each about 2.5, 3 feet long. And at the end, I've got a piece of 22 gauge wire stripped on both ends and taped to each end of the stick. So when I hold this out here like this, I'm insulated, and I can take this in and short out the capacitor and just move them around, make sure it's shorted real good. And obviously if there is any charge in it, it will blow this wire straight apart, so at least it should. Without blowing the capacitor apart. So yeah, we're just going to go ahead and do that now. Grab it on the taped ends here. Make sure I have my electrode tips bent out, visible, ready to go. And I'm just going to work this thing like a pair of chopsticks. So I'm going to take one end, I'm going to put it in one side of the capacitor. Not sure if it's anode or cathode. And I'm going to take the other side and put it right in the back side of that piece of wire there. There we go. Twist those around, make absolute sure it is totally and completely shorted out. I'll go ahead and take it out and do it again. See if I can get it in the hole of that electrode. Nope. So I'm going to straighten these back out, go back in it again. I'll do the other side first this time. So I'll take one end and put it into the end with the wire that I couldn't get unplugged. Make sure that's in there real good, and I'll take my other end and put that into our exposed electrode and just move it around, make sure it's real good and shorted. Okay, I'm confident for that. So now I feel a lot better about coming in here and pulling on things that I shouldn't otherwise be pulling on. So that sucker's in there. I really want that to come out one piece. I don't want to just leave that wire on there. There we go. Alright, so we got the microwave oven transformer wires here. You do have one giant resistor that goes straight from one side of the capacitor to the chassis. And I'm not sure exactly what that's for. It actually might be a diode. I'm not exactly sure what that's for. So you're going to want to be aware of that when you come in here with your screwdriver. You're going to have to unscrew that as well. So I'll go ahead and do that first things off. I'll bring my screwdriver in here and see if I can get this loose. I can't do it with that. I'm going to need a longer screwdriver. Let's see here. Long. How about that? There we go. There we go. Coming on out. There we go. And it looks like on this particular one, the band going around the capacitor is the same screw holding that in as it is holding the resistor to the chassis. So now that I think I've got this good and loose, reach in here, I should just be able to pop out my capacitor. Easy enough, hopefully. Okay, my capacitor's loose, but that band didn't come out with it, so I'm going to go ahead and reach in here. Try to just get that band out of the way. There we go. And there's our capacitor right there. I know it's discharged, but I'm not going to just touch it for fun. I'm not an idiot. At least not all the way. Set that off to the side. Now from here, I wanted to get this little circuit board out. And that's just going to take some screws. Ground chassis tie here. There we go. One there. One there. There we go. Should pop on out. There we go. Very nice. And let's see where these wires are going. I'm going to go ahead and start cutting these zip ties and things. There we go. This one wire goes to this thermistor here, or this thermocouple, whatever it is. There we go. Got one. Cut this other zip tie here. There we go. There we go. Got another zip tie down here. Plenty of zip ties in these. Alright, follow that blue wire and see if I can get down all the way and unplug that blue wire so I can leave the wires with this this small power supply rectifier unit here. There we go. And it looks like the blue wire is going right down to another plug. Looks like for the door switch. Yes, as you can see down there, the door switch is activated down there when I close this. It looks like it's redundant, so there's actually two switches, and if either of them are open, this thing will not run, as far as I understand. So because that comes and jumps, I'm just going to go ahead and try and unplug this. There we go. There we go. There's our pretty little unit. Fuse and rectifying unit. I'm pretty sure it's what it is. This cord should just pop out. There we go. Very nice. Nice piece of line voltage cord with an end on it. Useful. Okay, from here, where do I want to go? I think I can go back here. Start worrying about these hinges to get the door off, but before I do that, I see a lot of screws up here. It might be worth taking apart. Let's go ahead and do that now. Make sure you're still recording. Yes, we are. Good. Alright. Keep moving along. And of course, I mean, not every microwave is exactly the same, but that one big capacitor is the one you really got to watch for. But obviously, if there are any other capacitors that you notice in this thing, they need to be discharged, especially if they're anything over like 50 volts. Definitely need to be discharged. So be careful with your hands, always. Don't get shocked, please. Make sure you're always discharging this stuff properly. Okay. One side of the door came off. Go ahead and flip it around here. Looks like our microwave transformer actually came undone here with that. I'm going to go ahead and unplug the magnetron wires here if I can. One down. There we go. Looks like we got a couple little wires down here. I'm going to go ahead and try and lift the transformer out. Man, these things are heavy. Alright, one down, there we go. Alright, now we have our microwave oven transformer. This sucker puts out, doesn't actually say, but I believe it's somewhere upwards of 5 or 6,000 volts, 5 or 6 kV, something like that, unless I'm blind and it's right in front of me. I just can't see it. Very good, nice big oven transformer, good for the parts bin. And let's see, what's next? How about the top side of the door? I can see I can get to these screws now. And that actually should pop off in one piece. There we go. Microwave door. Very nice. Set that off to the side. There's pretty much no metal in that, so that won't be going to the metal man. Okay. Now from here, I want to try and get that control board out. Oh, there we go. That's a big part of the bottom chassis there. That's all metal. That'll be going straight to the metal man. Actually, here's my keep for the capacitor here. So in case you didn't see it really in the machine, it goes something like that. And this resistor went down to this screw hole here and held the whole thing together. I'll just go ahead and leave that with the capacitor. Put this away for the metal man. And I keep moving right along. Let's see, I think I've got some keeps here, some feet. Now I'm going to want to wedge out of the way to get this control board out. One. Pop back in place. There's one. There's two. And I got one screw back here. There we go. There's my control board. Go ahead and pop the connectors off of this thing. There we go. There we go. And there we go. So I took another microwave apart, very similar. And as you can see, they are very, very close, but they are also drastically different. So I think the difference here is that on this unit, there's a little bit more controlling going on, so there may be a couple more options to this controller board. But the biggest difference is the power supply for this thing. The unit is actually on the circuit board, like you would expect. Whereas on the one we just took out, the power supply is its own unit. So I would bet that this whole control board, this whole power supply board is made by a completely different company, shipped to the manufacturer of the microwave, and soldered on, glued in place right there like that. There's a fuse built into this thing too. So if nothing else, we got a little buzzer. There's a little piezo buzzer there. That's nice. I didn't know if the other one had that. Oh, it does. Okay. Well, very, very, very similar. Very similar. I think this one just has a few more options, like I said. All right. Moving right along. Those will go in the pile. Want to get in here to these limit switches. Go ahead and unplug them. Man, I hate these connectors. They're good once they're on, but trying to get them off is a pain in the ass. I'm going to slip and cut the shit out of myself because this chassis is not dull. There's all kinds of sharp edges on this thing. See if I can widen it up, squeezing the sides a little bit. There we go, got it. Alright, try and get these wires out of the way. Get it out of the conduit. Go ahead and unplug my turntable motor. Got the turntable motor down there. We'll get that out in a second. And back here, this goes to the fan assembly. I think that runs on mains voltage. I may be wrong. Try and unplug the rest of these thermocouples while I'm here. Oh my god, I hate these. Jesus. Oh, this is the light bulb socket. That's what it is. It's not a flow meter or anything like that. It's a light bulb socket. If I give this a twist, oh, there's actually one screw here. Twist, that thing comes right out. So we got a socket with the bulb. I think this bulb also runs on mains voltage. Yes. 125 volt, 20 watt bulb. Good to know. Man, I hate these connectors. They are such a pain. They're the worst to try and work on. You can't get them undone. Any tips you guys have for getting these stupid ass clips undone, please let me know. If they don't come off right away, then they have to be destroyed or cut off or something. That's what I'm going to do right here. There we go. Easy enough. I'm not going to waste too much time on that stupid piece of metal. Alright. One more screw here. This thermocouple or this thermistor, whatever it is. Got that off. As you can see, this basically just sits up against the chassis, the metal of the chassis. But basically, as it's sitting right here, if a fire develops inside the chassis, it will heat the case up enough to heat this thermistor up, and when this thermistor heats up, it kills the whole system. So it's just a safety mechanism. There we go. Set that off to the side. There's one more back here. There we go. Last thermocouple there. Okay. And it looks like I should be able to get the magnetron out relatively easy now, so I'm going to go ahead and take this this small ducting off. Looks like I've got another screw couple on the back side here. There we go. Little guard there. I think that's where the let's see, what was that? Oh, that's for the light. That's what it is. So you actually have perforated holes in the chassis, and this is just a reflector. So the light bulb goes through there, sits right there, and reflects all the light inside the chassis of the actual microwave. Set that off for the metal guy. Now the big boy, the bad dog, the scary part. Got one bracket on the top here, 3 screws. Enough. Set that for the metal guy. And it looks like we've got one screw on this side, and I think the whole thing kind of tilts out like that. Go ahead and do this with the ooh. It is magnetic, no doubt about it. There we go. Now this is the most dangerous part, aside from the capacitor. This is the most dangerous part of the entire microwave. So once you have the capacitor out of the way, you're about half done. So now that we have our magnetron undone here, we're going to very carefully tilt this out get it out of here very carefully. Now what you see here is a pink band made of beryllium. If I can get up here and show you, on the magnetron, that pink band made out of beryllium is incredibly toxic. So if you start pulling this thing out and that breaks, or you notice it's broken already, stop what you're doing, throw the entire thing in the trash can, close the lid, and wait till it goes away. Because you can't get any of this in your lungs. If you absorb any of this, a beryllium toxicity of some kind, but it's incredibly toxic. So do not get any of this in your lungs, in your nose, on your hands, anywhere. Make sure it's all intact, and if it is, you're going to want to very carefully set it off to the side where nothing's going to bump it. Now that we have that very carefully set aside, I'm going to go ahead and start getting the door mechanism out of here, all the limit switches, all the redundancy. So as you can see, there's actually 3 limit switches on this. So you have 1 for the top clip and 2 for the bottom clip. So I think 1 might be the door open mechanism. When you hit the door open mechanism, see that? When you hit the door button to open the door, that kills the whole system. And then you have 2 which check the top lock and the bottom lock to make sure they are engaged. So when it's closed, there you go. When it's open, break the system and the whole thing quits running. So with that, I'm just going to pull these limit switches out. Try and put these off to the side if I can without breaking everything. Too late for that. There we go. 2 and 3. Alright. So with that, we've got a little pile of limit switches here that can be used for absolutely anything. I don't know if they're normally opened or normally closed. I would assume they're normally open. Set those off to the side. That goes in the trash can. Now all we have left is the turntable motor and the fan itself. So I think I'm going to actually worry about the fan. If I go to the back side here, I can see there are 2 screws, so I'm going to try and hold the fan with one hand. Pop these out. There we go. And with that, should just pop out this side and then slide out the feet. Oh, wind kicked up. Give me 1 second. Sorry about that. We got a storm coming through. Good day to be in the garage. Okay, and this big nasty plug here should just pull right out. Then you got 2 connectors. Terrible connectors. That will be cut. Not going to waste any time at all with that. And all of this wire can be either thrown in with the metal guy for copper or thrown right in the trash, because it is not worth much when it's not stripped, and especially with all this plastic and stuff on it, it's considered dirty, non-stripped copper, and you don't get very much for that as opposed to being stripped clean copper wire. So set that off to the side. Got 2 screws here holding in the actual fan. But before I do that, actually, you notice the blade is on the actual shaft on the opposite side of this housing. So I'm going to take a flathead screwdriver and see if I can pop the blade off. Easy enough, and it is a keyed blade, so it has one flat end on the shaft. How it goes on, you can tell that very easily. I'll flip this back over and go ahead and pop those screws out. There we go. Ease the motor out of here. Go ahead and put our fan back together, just to keep it all together nice and clean. There we go. Oop, too far. There we go. Very nice. Little tiny fan. Set that off to the side. Trash. And all that's left is the turntable motor. We've only got one screw here, and the whole thing angles out of the chassis. Twist, pull. Very, very simple. Now this motor, as far as I understand, being 120 volts, it is actually a gearboxed motor. So as you can see, the circumference of the motor is actually offset from the end of the output shaft. So I think the small amount of torque that's put out by the motor is doubled, tripled, even quadrupled through a small bit of planetary gear system inside the motor. So that's a useful bit of information. Put that in the pile. Actually, I'll put all this stuff over here. I keep mixing it up. There we go. Okay. Now you have a big chunk for the metal guy. Or there is one more thing we can do with this. If you've ever heard of a Faraday cage, it's a device that is usually surrounded by meshed steel, concrete, sand, water jackets, whatever you can get, basically surrounding a small area that you can access and store electronics. So if we did have a Carrington event, which is a strong solar storm that would knock out much of the electronics on the planet, if that happened, a Faraday cage would be a fantastic place to store a couple Arduinos, a laptop, whatever you can think of that you might be able to use if all the electricity just up and died. So if you had a small solar panel in here, a couple Arduinos, a bunch of limit switches, you can pull all that stuff out and create an entire alarm system for your house based on that. So it's good to think about these things in a hobbyist sense. So I've done this before. Basically what I do, I would take the bottom chassis, I would put that back together. However it is it went, I think I might be the wrong one here. There we go. So I put the bottom chassis, I'll throw a couple screws in here. Just a couple. Just for demonstration purposes, throw that bottom chassis back on. Take your top chassis, put it back in place over top here. Throw a couple screws in that. There we go. If I throw some screws into this chassis, just temporarily putting it back together. Good enough for there. Go ahead and take the side screw. There is one screw on the side of this chassis. Direction. There we go. There we go. Basically putting the shell of the microwave back together. And if you notice, the door, which is worth almost nothing to the metal man, does have this perforated kind of steel area, and you can actually lay steel and things over this. You throw the door in there, you'd have a locking mechanism like that, and you basically have a Faraday cage. That simple. You just throw the shell of the microwave back together, and you're good to go. You can bury this, put some stuff in it, put some Arduinos in it, whatever you want to do. This is actually good. This whole thing will go to the metal man. Very good. So now let's see what we got. What was our haul like on this scrap venture? We have a time control board with 120 volt relays. So this will turn on an alarm, a heater, anything like that, you want to keep in mind of the current and things that you're drawing through these relays. You don't want to catch anything on fire, but it is a useful hobbyist kind of thing. On top of that, of course, we have the big bad capacitor and our microwave oven transformer. Cool beans. We got a used cord. We have our rectifier kind of power supply unit here. I think this is just the rectifier, like I said before. We have a motor that's geared down, puts out quite a bit of torque for what it uses in power. We have a fan. Now we could actually put any kind of thing on this shaft, so it doesn't have to have this blade on it. You can use this for anything. It's basically a high RPM, low torque setup, so that it's only useful for a fan, pretty much. And we've got a socket and bowl, a couple thermistors, and a handful of limit switches. That's what you get. I did forget one thing. One of the most important parts of this whole thing, one of the most safety influential parts of this whole thing, we have the beryllium ring on our magnetometer. What do we do with this? The unit itself is useless. There's nothing we can use it for except for hurting ourselves. So what I'm going to do is I'm going to take some used shopping bags. I'm going to set the magnetometer inside the used shopping bag. I'm going to spray this down with water. I'm going to take the bag, tie it shut, put that inside of another bag, spray it with water, and then tie that shut. Now what the water is going to do is cut down on any dust should that beryllium ring break. So we've got it double bagged, wet. That's about as safe as you're going to get trying to get rid of this thing. From there, obviously, black trash can, dump run, whatever it is, but make sure it goes in the right place safely. Thanks for watching. Take care.